This is the first of a set of videos that in which I'm going to introduce you to Python basics. Um, so most of those are going to be divided into two parts. The first part is kind of an overview of what I'm going to demonstrate, and then the second part is demonstration. So I'm going to do stuff, write commands on the fly or in a script, and then you will see what's happening. Okay, so let's start from the basics, which is script. Python is called a scripting language, meaning that every code that you write in Python permanently is going to be stored in a script. Script is simply a text file. You can open any Python script in Notepad, for example. But what makes it distinct from lower level languages is that it really handles, or you explicitly write the most important stuff to solve your problem. So there is a lot of technicalities in the background that are being handled for you. That's why it's a program written in high-level language. There are other scripting languages, Perl, JavaScript. We select Python for a number of reasons. The first one is very useful, especially for beginners, which is no variable declaration. I will show you in a moment what it means, but for now what you have to understand is that whatever you put in your variable, Python is going to declare itself. You don't have to say, my variable is going to store text. This also for people who are familiar with other languages like Java, for example, where you have to declare variable explicitly, it might be a little of a disadvantage, but Python does do lots of consistency checks so that there is no problems with the fact that the variable has not been declared by you. And then the more important thing is that Python comes with a ton of standardized libraries and tools. A big number of them comes with core Python. So if you go to Python website and download just Python without any like all-in-one platforms, just pure Python, you still are provided with a big library of a lot of different tools that you can use. On top of that, there is a big and ever-growing repository of tools that are developed by people all over the world, researchers, business people, IT specialists that perform specialized tasks, which you can download from the website and use in your script. So a lot of stuff has been done for you. That is good because then you don't have to reinvent the wheel. Python is essentially being equipped with some form of kind of a word processor. So you have a special type of shell where you can write your code. There are two different pieces to it. You have the interactive window, which is temporary. So you write a line of code, something happens, another line of code, but when you close your interpreter, everything is lost. And then you have another window, which is a script window. This is where you really write your script. So if you save that script and you can then reopen it again, it's going to have this code saved. So that's permanent. The shell, Python shell, is called idle, and this comes with core Python installation. I'm going to show you that, but I am not going to use it. As I mentioned in video 1, we are going to use Anaconda, and specifically programming environment called Spider. But I will show you idle just to kind of, let you know that there is something out there that comes with your core installation. All right, so what are the basic structures of Python? First, you have variables. Variable is essentially a container for your value. So it's a name, okay? It's a name for a value. So if I write x equals 2, I'm saying that variable x, the name of my value 2 is variable x. A variable is not really a container directly, in a sense that you do not store it, your value, in the variable. It's more like a pointer to some value in memory. And again, because Python is dynamically typed, you do not have to declare them. You do not upfront say, before you write x equals 2, like in, okay, come on, like at the very bottom, you just, you don't have to say initially x is going to store integer, and then you write value or assign value to your variable x. That is what it means, that you don't have to declare your variable. Now, expression, so variable is a name. Expression represents values, so is something. So expression is basically kind of like a combination of values. So 2 plus 2 represents 4. My string represents text. And finally, we have statements, which are instructions to do something. And the very basic one is assignment. When you write x equal 2, you assign value 2 to your variable x. Python dynamically types your variables or declares what type of content a variable stores. So I do not have to say, as I mentioned before, I don't have to say n is going to store text. I'm just assigning value to n, and Python immediately knows by looking at this value that that's going to be text. So you don't have to define the type of your variable. And the same as here. So if you write n equals 125, Python immediately knows that that is integer. Okay? Variables are case sensitive. So this variable features equals freeways.shp and uppercase features. These are two different variables. There are also specific words in Python that perform specific tasks. They are called keywords, and they are reserved. So you cannot use them for a variable name. You cannot, for example, say if equals 2. That is incorrect, because if is a keyword and it does specific thing. So Python's going to complain. And again, keywords are case sensitive. So if you want your keyword if to do something, if you write it with uppercase, for Python, that's going to be a variable name. Okay? So you have to be careful with case sensitivity. The naming conventions for Python are when you create a very long name which has multiple words in it for your variable, the convention is to use underscore, because the variable name has to be one set of characters. You cannot write town space name. Town space name would be interpreted by Python as two different things. So you have to use some form of combining, some way of combining those two words to name your variable. And one of those is to use underscore. And that's what we in Python community try to enforce. But you can also see this type of naming convention where essentially to show you that there are multiple words that stand for your variable name. Each of the new word is capitalized. That is common in Java, for example. There are some characters that you cannot use because they also have specific meaning. So if you put into your variable a % or hashtag or // that is also going to be incorrect, and Python is going to complain. There's going to be an error. Finally, please do try and use variable names that actually mean something. It is more typing, of course, but it gives the reader of your code, it can be you a year from now, or it can be someone else that you shared your code with. It will give that person much more, it adds clarity to what's going on. So an example, it's better to write square underscore area equals side times side versus SA equals S times S. Okay, that is not the best convention. So try to use descriptive variable names. All right, I mentioned expressions, I mentioned variables, but there are also things that are called functions. A function is very simple to understand. A function is a piece of code which is going to process the input in some way and produce output. So you provide some arguments or some inputs to a function, and that function does something with that input, and then it returns an output. That's the whole magic behind functions. You will have a lot of different functions you're going to deal with in the future, but there are some functions that come directly with Python, which are called built-in functions. So for example, you can use len, which is going to return the length of your value. There's going to be max, which is going to return the maximum of your numbers. There's going to be round, which is going to round your number. In this case, by default, it's going to round to the nearest integer, but you can specify how many digits you want as well. Print is another function that is very useful, and you're gonna use it over and over again. Example in a moment. Numbers. So we have text, which is called string. That's one type of data type. We also have numbers, and these are divided into three types: integers, floating points, and complex numbers. Forget about the third, at least in this class. You have to understand what an integer and floating point is, and it's very simple. Integers are just whole numbers, floating points have decimals. So they are with fractions. And then you do some operations with numbers. Some of those operations are just mathematical, like you add two values together, you divide one by the other, and some are kind of a more programming specific. The first one is assignment, where you basically use the equal sign to assign a value to your variable, and type, which allows you to check what that variable really stores. Type is very useful because you do not declare your variable in advance. So after a lot of lines of code, you might have reused the same name for different things. So at a certain point, you want to make sure that actually this is still a string, or maybe it's an integer, so you use built-in function type. Float versus integer division is no longer a problem in Python 3, which we are going to use in our class. But I'm just mentioning it if you encounter old code, 2.7 and older, Python 2.7 and older, you might encounter this kind of a bizarre behavior when you divide two integers, one divided by the other, and they produce floating point. It produces basically a decimal. You will see actually an integer in the output. So say I am going to divide 5 divided by 2. Well, you would essentially expect 2.5, but because integer divided by integer equal integer, the result would be 2. So that's a little complicated. Right now in Python 3, we don't have to worry about it. It doesn't matter. You have an integer divided by integer. The expected result, if there is decimal, is going to be with decimal. So numbers is one data type, strings is another. A strings is a sequence of characters, right? So what it means, a sequence, is that you have characters in specific order. String is actually an object. Actually, string per se is a class, but when you have a variable which stores sequence of characters, that's an object. We will talk about object-oriented programming later on. For now, you just have to remember that this is how object methods or functions are defined. So classes, well, just a little bit about OOP. You have a class from which you create objects. The beauty about that is that you can define methods on that object. So this is sort of like a function assigned to that object. So it's not standalone function, like for example print. It's a function that's assigned to that object. We usually call it a method. So it takes arguments just like other functions and returns some output by, crunching or playing around with those values. And a string is such an object, so what it means is that there is a number of methods that you can use with your string. To kind of inform Python, this is the whole string, the text I want you to store in variable v. You have to surround it by double or single quotes. It doesn't matter which one you use, that's exactly the same. They become handy when you have to use quotes within quotes. Say you are quoting someone else's something that someone else said, then you have to use both of them. So because you don't want to confuse Python, you can use double quotes first, and then for a quote in your text, you use single quotes. Strings can be combined, so you can have one sentence, one string, another sentence, another string, and then you combine them into some bigger text, chunk of text. It's called concatenation. Of course, the opposite is also possible. So let's say I have a sentence and I want to extract every word from that sentence. Then I can slice my string. We sometimes call these sliced pieces substrings. I mentioned that a string is an object and it has methods, and a string is an object that, or let's just not complicate things. Let's stick to object. We'll explain class differently between class and object later. So string is going to be an object that has methods that are built in. In other words, someone else who created Python defined those methods on strings, so now you can use them. These are capitalized, upper, lower, count, find, and so forth. And there are some strings that have specific meaning. So if you encounter something like, that's backslash, right? Backslash n, that means Python is going to interpret it as a new line. So you have one sentence, you have backslash n, Python says, okay, move to the next line and then print whatever is after that. And then you have backslash t for tab. So in this case, Python's going to insert tab between the pieces, between whatever text is before and after. Okay, so that's as far as I'm going to talk about kind of a dry information, and let's now move to demo. So I'm going to show you idle just for the sake of understanding what comes with core Python. Let's see. Okay, I don't use idle a lot, so I have to actually find it. Now, I have multiple idles because I have two different installations. I have ArcGIS that uses still Python 2.7, so I have to have Python 2.7. So this is my Python 2.7 and this is my Python 3. And again, I want to stress that we are going to use Python 3 in this class. So you have to open idle for Python 3. Don't worry, you don't have to use it. You will not use it, just kind of to give you a feel of how it looks. So you have some information about the shell, the type of Python it uses, and then you have this interactive window. What it means is that you can do something like that. So this is one line of code, and this is actually a function, so it returns some value. You can do something like x equals 10, and then y equals 12, and then display x, and then display y, and then do x plus y. Okay. The moment I close shell, all of that is gone, because that's interactive, it's temporary code. To save it permanently, I have to create a script. So to do that, I go to File, New File, and this is my script file. Because you doesn't have any extension, there's not gonna be any coloring here, so I'm going to save it first. Let's save it on desktop. Let's call it silly2 whatever .py. Okay. And now I'm going to reuse this code just by, typing it again, but this time so that I can save it permanently. So first is print Arica. Okay. Then you have x equals 10, then you have y equals 12, and then you have x plus y. But in a script, I can't, this is not interactive, so I can't just write x plus y. I have to either print it or store the result and then print it. Okay, so I can do print x plus y. So it means that Python's going to first add x and y and then print it, or I can do v equals x plus y and then print v. Okay, so we're gonna save it and we're gonna run it, and I'm gonna just run it like that. See, so whatever was in silly1, the rest is obviously hidden because I do not produce any output. I'm just doing assignment in my script, and then it prints the result. Now let's close it, and I'm going to reopen idle free. So as you can see, whatever I typed in is gone because it was temporary, but I still have my file on desktop. It's called silly1, and I can execute it. That's it. That's all I want to tell you about idle. We are not going to use idle. Idle is very simple, it's very intuitive, you don't have any fancy stuff, but the code that we are going to work with, the models that we are going to work with, they are going to have multiple pieces to them. So it makes sense to introduce you to kind of a more sophisticated model programming environment. And if you did your homework from video 1, you should have it installed right now. So that's the general platform is called Anaconda Navigator, and the specific editor that we want to use is called Spider. You can see I have them here. So we're closing everything and move on to Spider now. Come on, oh, yes, you don't see it, but actually I had it open. I want to get rid of all that stuff. I was trying out some things before, so, and I forgot to close. So I'm going to reopen it now with clean slate. Okay, so for now, I just want you to kind of look at the different panes. So here you have a toolbar for executing your code from a script you have to click on this. You can open file. This is kind of a standard tools that you have. Now there is also this bar. This bar allows you to navigate to specific folder and keep yourself there. So I have, for example, I have a model in one of my folders. Now I'm going to just browse there. Yeah, it's always a problem of, oh, there you go. And then I just copy it. Oh, select folder. Doesn't matter. So, you just have this path to your folder, and then in here you have File Explorer with all the content in that folder. That's very handy. You just have kind of an insight to what's in that directory and its whole path here. Then you have the script pane and the interactive Python. Okay, I am going for now to close all my scripts, and this was just to show you. I want to go back to desktop because I have simple scripts there. And now, of course, there's more stuff there than just my script, so everything has been displayed here. All right, let's just leave the script pane for a while and focus on interactive interpreter to show you a little bit of those basic Python stuff. Okay. Oh, before I do that, I just want to show you, we created this silly.py. Let's open it. Actually, it was silly1. Right. Here you are. That's our silly1. So I created it in idle. Now I opened it in Spider and run it. And of course, it did what it was supposed to do. So just, you create a Python script, it's gonna be executed on in multiple different programming environments. Okay, so let's start from variables which are dynamically typed. Okay, so I have variable v and it has 12. So I assigned value 12 to my variable v. Now I can check. So I didn't tell Python that v is going to be integer. I just assigned integer 12, value 12 to v. So, but I can always check what Python by itself dynamically figured out from the value. Oh, and something that it's not really surprising, the type is integer. Now, if I reuse my name, but now have a float and check for type, Python basically substituted 12 with my floating point number and changed the type to float. Okay, so it's a dynamic declaration. You do not tell Python v should store integers, and then if you try to assign floating point, then Python would complain. You said that v should store integers, and now you're trying to put float into a variable that is declared as integer. That's not what happens in Python. Python's going to look at the value every time and then interpret what data type should be used. Now, I showed you a few built-in functions. Let's just list all of them. So you can see there's quite a few. Many of them are errors. Many of them are things that you will never use, but there are also those that you will definitely use, like for example, let's see, int, that's just used it. You can have len, which calculates the length of your string, for example. You can have open, which allows you to open a file. You can also have print. Where is print? Oh, there you go. So those built-in functions are directly available. You don't have to import them, you don't have to look for them. They are there. You open Python interpreter, all of those functions are readily available. So I can just, and I don't want to combine. Okay, I can just use maximum, for example. I have a list of values, 1, 2, 3, 4, 5, 101, 1, 2, okay? And then I want to use built-in function max. It's going to basically find the maximum value of my list of numbers. Nothing really surprising here, but I didn't have to do anything. I just called this function because it's built in. It's available immediately. The one that we are going to use over and over is print. And there is a few things you should know about print. Print takes a number of arguments, which are usually combinations of numbers, names of variables, even standalone strings. So you don't have to really assign a string to a value. You can put it directly in the print statement, and what the name suggests, print is going to print whatever arguments you put into it. So for now we have v. We have v, and let's say we have another string, another variable s, which stores text, and then print. And this is what I can do. I can type v is, oops, what this is a and s. Well, Python basically combined it, immediately recognized that there should be spaces, and combined it together and displayed the result, printed the result. And I put a number of things here. I put a number, I put a string that's not assigned to anything, and then I put a string that is value for my variable s. Okay. So I said division used to be a problem, now it's not. So if I have integer 5 divided by integer 2, it produces a floating point number 2.5. You know, something we would expect. Okay. So let's check for type of V. And now I'm going to change the value, and let's see what the type of V is now. So as you can see, I changed the value assigned to V from what was that V? Oh, that was our value, from float to integer, and Python automatically changed the type by itself. Okay, you have to be careful what you're typing. So we have another variable x, and variable x is going to be v plus, well, this is 1, right? So we would expect 118. Unfortunately, Python sees it as a string. Remember, I told you strings are surrounded by quotes. So you cannot really add 1 to it. That's not going to work. So you have to explicitly convert this to integer. So let's say I have I'm going to make it a little more. 1, which is variable name, equals 1, and now I'm going to do x equals v plus convert it to integer 1, and then x is 118. Okay, I mentioned that value is not really stored in a variable. A variable just points to a value which is stored in memory. That has specific implications. Let's work with 3 variables: variable A, variable B, and variable C. So A equals 1. Okay. B equals A. Now, what can I do to show it? So right now, let's see, B is 1, right? Because B equals A, which is 1. Now I am going to do something like that. That's a shortcut for take the value, whatever is in A, and add to it 1 and assign whatever the result is to A. So that's assignment with addition. And then let's see what A is. We would expect that B, because B got assigned value of 1, then B is still 1. Let's see if that's true. I don't really know. That's not what I would expect. That must have been handled somehow in Python 3, because what would happen, and I've never tested it in Python 3, so that's surprising for me, is in the past what would happen is that because B points to A and I increased the value of A by 1, B is now going to point to A, which is now 2, so B would be 2. But it's not. So I guess that's confusing for me, not for you. For you, it's something that kind of makes sense. For me, it's confusing because I was taught something different. Never mind. I am learning something new too. Okay. All right, so what else? All right, so a little bit about the functions defined on strings. Okay, so first one is capitalize. So we'll start from a string that is gonna have value that is the name of my dog. And well, its name, so you would probably like first letter to be capitalized. So let's do it. Let's do dog. Okay, nice. It did what it was supposed to do. Well, let's see what dog now looks like. Well, this particular method was executed on value, the current value of dog. That was done, but I haven't really caught this change into a variable. So it was executed and Python forgot about it. If I want it to be stored, I would have to use another variable to store the result of this function. You can reuse existing variable names, and that's what I'm going to do. I'm just going to say my variable dog is going to be previous value of variable. So what this sentence says is take the value of dog, capitalize it, and assign it back to dog. So now if I display the value of my dog variable, it's what I would expect. You can also combine, change all of the letters to uppercase. So you can do dog. Then you have all of them uppercase, and so now we are back to rebel without upper R. Let's now move to a little more complicated case. So I am going to write a sentence now. But to make it a little more difficult for you, instead of writing the whole sentence, I am going to reuse the variable I already have. So let's call the variable crazy. It's not particularly descriptive, but it's short, which is important now because I don't want to type too much. I'm a terrible typer, very slow, so the shorter the better. Anyway, so I'm going to do something like that. Dog plus is crazy. He chases rabbits. Okay. Oh, sorry. All right, so let's see what crazy now is. It's not really what we wanted, right? So that's concatenation. We simply added to a string to another string, but Python doesn't know that I want a space. It just takes whatever I put it, into this assignment. Now we can fix it, actually. We can fix it in a number of ways. The simplest would be to reuse this, just, insert my space here. And because now, now that would give us, the proper result. So you have to remember, when you concatenate strings and you want white space between them, you have to type it explicitly. Python's not going to do it for you. Okay. Let's say you want to know how many A's are in your sentence in crazy. Now you can do that. Just use count. And what do you want to count? You want to count A. And there are 3. 1, 2, 3. All right. Let's extend it's not very into it's a silly example, but first of all, what am I doing here? And that's a different thing than math, right? You have to be careful because it's an assignment. Assignment works in this way. Whatever is on the right side is being executed and then assigned to variable. I already have crazy, so what I'm doing now is I'm telling Python, take crazy, whatever's in crazy, add to it or concatenate it with this word and assign it back to crazy. So what's crazy now? Yeah, as I said, this is a silly example, but it serves a purpose. So we calculated the number of A's. Now let's see, let's calculate the number of E's. Okay, so there are 4, but I have also 2 E's here, right? 1, 2, 3, 4. There should be 6. Well, it's not, because as I told you, Python is case sensitive in every respect. For Python, this is a different character than this one. All right. So to count all of them, I could do something like that. And then, so I convert it to upper, and then I do count, and then I do E. Okay, so, whoops, of course that was not what I intended because I put it to upper, so there's no lowercase e's in my result. This is combining multiple methods together. That might be a little confusing. What happens here is then Python interprets it as this. Take my string, convert it to upper, and whatever the result is, I want you to count uppercase e's in it. You could of course split it into two different lines. So you could do something like crazy equals crazy upper, and then so crazy now is uppercase, and now crazy count what we can counting e. Okay, right. So that's another another way to do both of these things separately. Okay, so this is equivalent to those two lines of code. Okay, so let's move on to replace. You should have noticed that I made a typo here because I should have had two B's, right? BB. So now I am going to correct that. And one of the ways to do it is use replace. Okay. So what I have to replace is I want to replace rabbits, okay, with the proper one, which is rabbits, right? Oh, let's see. I don't want to change. Okay, of course. Comma. And I want to, oh, sorry, forgetting about. Okay, and I want to assign it back to crazy. Well, not this crazy. I want to use this variable. You have to understand that this is a separate, this crazy is a separate string, and this is new crazy, new string, okay? So I am doing some operation on my string. There is something new created, and that new thing is assigned to a variable. And I just want to reuse the same name. So I am writing crazy here as the same variable name. All right, and let's just check. Now it's correct. Now, I want to show you that you do not, you are doing an operation on this variable, but this is a separate thing from this. Okay, so now and crazy all right, another thing that bothers me. Oh, okay. I understand what I did wrong. So I am going to have the first crazy. I see what I'm gonna do because you probably got lost and me too. Crazy equals. Okay, that's my one sentence. Now I'm going to correct the typo. So I'm going to use a different variable name this time. Replace rabbits with 1b with rabbits. Okay. Oh, I made a typo. All right, no problem. Oh gosh, right. Lace. Okay. So now this is what I wanted to show you. My initial crazy was modified, but it didn't change. I just used the initial crazy, did something with it, and created a completely new string. What I am doing simply in this previous example is I am reusing this variable. I know I am not going to use it anymore, so I just create a new string and assign it to the same variable. But you have to understand that every time you apply any method of your object of string, you are creating a new string. We call it that strings are immutable. Okay, tuples are also immutable, so you will have another immutable objects later on. So that was replace. Now you can also ask for index. So let me talk a little bit about the string as a sequence. Because string is a sequence of ordered characters, every character has its own location, and we call that location an index. You have to remember that index starts from 0. So L would be, now, it would be 0, 1, 2, 3, 4. So even though you count 5 characters, because the first character has index 0, you really assign, so our index is 0, and then you count from 0, 1, 2, 0, 1, 2, 3, 4, and so forth. Okay, so just to show you this, okay, let's see, R. There you go. So the first R is going to be 0, okay? That's the first letter, the first character. That's what we expected. Now you might say, well, but actually there are multiple R's in this sentence, right? So why did I get only 0? Because Python is kind of a lazy here, and it just encounters the first R, gets the index and returns it, and that's it. If you wanted to have the next R, you should tell Python where to start counting. So I'm going to repeat that, but now I don't want to start from the beginning. I want to start from index 1. And then I got here, which hopefully is 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay. I don't know if I mentioned this, so let's use len, which is going to return the length of our string. So that's 33 characters. And then we can also subdivide our string into substrings. Now, how can you do that? Well, you can use strip. All right, so strip is for slicing your string into smaller strings. What I'm gonna do now is I am going to I said strip, I meant split, sorry. So split, as the name suggests, divides your string into smaller strings, but you have to tell Python what character to use to cut your string. So it's not just split and then Python doesn't know. Okay, what should I use to cut the string? So let's say that in this case we are going to use white space. Okay. All right. So as you expected, we got substrings. This is a list. We will talk about lists next time. Just, you kind of understand you have multiple strings instead of one. You don't have to use white space. You can use the whole or multiple. Let's see. You can use a word as a split thing. To do that, I am going to do some combination. It's gonna be a silly thing, but it will show you what I want to show you. So, okay, now I'm going to replace space with something like that. A, B, C. Okay. Let's see what I have now. Of course. There you go. Crazy hasn't changed. Well, there is kind of like a mess here because instead of spaces, I now have this substring. So what I can do is now I can split using a set of characters, not just one character. Okay, so go back to split, and now let's split at. All right. Oh my gosh. Sorry. I keep forgetting that we have our crazy and C. So not crazy split, but C split. So it used this at character, and then whatever was in between was split or divided by substrings. I can also do something like that. Okay. Now I want you to figure out why is that on your own. Okay. So that's as far as split. I'm going to now introduce a special character. So to do that, let's see. We have our crazy variable, which is with the type. So crazy equals crazy replace. I'm gonna correct that because it bothers me. So yeah, right. How about A? Okay. And I don't want to. I think we should finish soon because I'm making more and more mistakes. Okay, so I guess this is what I wanted. No, that's the sentence I wanted to have. Okay, so now let's introduce new line character. So I'm going to have new news s for new string equals crazy plus new line plus crazy. News. Okay, this is this is not what I intended, but that's what happened. Okay, so this is my new news variable. And so what I did here is I introduced special character new line. Now output is essentially raw value. So in string output, this is just for displaying purposes. It's going to display the string as is. But this new line character has a purpose, and the purpose is to print a new line, so that all of that is not in one line, but you have this first, and then this first, then Python goes to another line and prints the second. So that can be done with print, because in print Python is going to recognize special characters, recognize the functions behind special characters. So let's print news, and there you go. I am going to add another new line. Okay, another new line. This is what I have now. If I print, this is what I have now. If I print news, this is what I get. Of course, this is just new lines, empty line. So now I have another line in between. This is one line, which is kind of a default in interpreter. Now you have two. Okay. So let's see. Suppose you don't want this ugly new line character at the end. You have another function to do that. You can strip your string you can strip your string with some stuff that you just want to get rid of. So you can do this by using, as the name probably suggests, strip. And now Python is going to look for default characters. Usually these are new lines, tabs, things like that. So now it took away this new line from the very end. All right, so strip. The last thing I want to talk about is, well, there are two things. Let's talk about join. It has a very, in my opinion, very non-intuitive syntax. Anyway, you can create a string which combines multiple strings into one and combines them and places in between them a specific character. See. All right. Okay. So let's have names. That is Erika, ALZ, Erika. Okay. So we have okay. We have actually, I don't want to have names. I can do that, but that is a little too complicated for you. So name 1. Okay, name 2, and name and then name 3. So I created 3 variables with strings. Okay, and get rid of that. All right. Now, suppose I want to combine all of these. I could use join. So you can have like 10, 20 different substrings and you want to combine them into one big string by joining them with specific character in between. So let's say I want to join these with space. So that's why I'm saying it's not intuitive, because first you specify the joining string, then you say join, and then you have to provide the arguments. Because join basically takes one argument and takes whatever is in there, we have to put those names into a list. Again, lists are later. Just think about it as a container. So I'm going to place a container with those 3 names. Okay. And there you go. I joined my 3 names. You can also do that. There's nothing wrong with it. This is an empty string. So an empty string is just a string without characters at all. And of course, it just glues everything together. All right, and the last thing is substrings, which are defined using indices. So there is a notation that I'm going to introduce a little more later, but for now I just wanted to show you how you can insert a string in between into a text that you already have. I forgot, I'm gonna reuse. Okay, that's not good. Crazy, I don't like this one. All right, so say I want to say Rebel is very crazy, right? So I want to insert very in here. Well, unfortunately, there is no such method or function defined on strings that is called insert. But you can obviously insert stuff. So remember I told you that we have indices. When I am going to add very, I am going to specify where exactly I want that very, all right? So first I have to know where to start, right? So I want very starting right here, okay? So let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now I know that I need to place my new word after 8. All right, this is not that difficult. Let's say I want new being crazy. Yeah, now I forgot the number. I was 8, okay. All right. So what does it mean? It means get everything up until okay, everything up until this one. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the way Python interprets this particular this particular expression is take everything from the beginning until, but not including 9. Right? So you will have lists. I will explain to you how it works a little more. For now, I want you to understand that this particular expression is going to take crazy and just store in new whatever is up until index 8. Let's just try it to show you how it. But that's what we wanted, right? We don't want C as part of it. Okay, so I said I want to include vary, right? So now I have the first piece of my code, and the next one is pretty straightforward. I just have to write vary. So my new is going to be crazy to 9, which means include everything but 9, plus, who cares, it can be lowercase. Of course, remember, you have to use space or white space explicitly. So I have to say, I have to type space. Okay, otherwise it's gonna glue vary to crazy. Okay, and let's see what new looks like now. Okay, so what I want to do now is I want to add everything else to it. It's gonna be pretty straightforward. So I'm repeating this, and then I am taking everything from 9 to the end. 9 to the end. Okay, let's see if this is what I wanted. Great. So this is a little more complicated code, but I wanted you to be prepared of what is to come, and obviously this is a crash course, so the indices and sequences, mutability, all that stuff is going to come pretty fast in our class. All right, that's it for now.